At GoPro, I lead a team that builds the eyes of GoPro's popular action cameras. And today I'm going to talk to you about building the eyes of a vision system. Let's begin by talking about light. What is light? Well, light can be represented as both a particle and an electromagnetic wave. And when discussing image sensors, we tend to rather casually switch between the two. A photon is a light particle, and the energy determines the wavelength. Higher energy means shorter wavelength. Energy equals Planck's constant multiplied by the speed of light divided by the wavelength. And when light is visible to human beings, we perceive different wavelengths as different colors. Intensity of light is equal to the number of photons. The human vision system is sensitive from about 380 nanometers up to 740 nanometers. Below 380, we have ultraviolet. Above 740, infrared. Let's explore the different bands of light in a little bit more detail. Visible, as mentioned, 380 to 740 nanometers. There, we can use CCDs and increasingly CMOS image sensors, CIS. Moving out beyond the human visual response from 0.74 micron to 1 micron, we can continue to use CCDs and, in particular, near-IR enhanced CIS. Between 1 micron and 2.5 microns, we have the shortwave IR band, and here we have to start using different sensor technology. Typically, for shortwave IR, we use in-gas sensors. From 3 microns to 5 microns, we're in the medium wave IR band with a number of sensor technologies, including indium antimonide, mercad telluride, and 3.5 semiconductor superlattices. And this is starting to move into the classic thermal imaging of heat. The next thermal band is 8 to 14 microns, long wave IR. Typical sensor technologies are micropolometers, and again, mercad telluride. You may notice there's a gap between 5 microns and 8 microns. That's because water vapor in the atmosphere absorbs light in that band.